Hello guys, I'm Dan. Today I want to teach you how to use Python to make a Gluttonous Snake. And here we go. The first step, we have to import the random and the cursive. Import random is used to generate the random number. In this case, it's used to generate the position of the foot. Import cursive is used to create a graphical interface, just for building the user interface. The second step, we have to initialize and set up the cursive environment. Basically, the steps go like this. We have to initialize the cursive and create a terminal window object, and hide the cross to make the game screen look cleaner. And this tool is used to control the terminal window. The last two, one is used to enable keyboard input. The other one is used to control the snake speed. Step 3 and 4, we are going to set up the position for the snake and the foot. This piece of code is used to set the initial position and the shape of the snake, ensuring it is displayed correctly on the screen when the game starts. The division by 2 and 4 is used to set its initial spawning position. Here is the picture. We position it as 1/4 of the screen wide and halfway down the screen high. The last three lines are used to define the shape of snake. The first one is snake head. The second one is snake body. The third one is snake tail. In this part of code, we place the foot at the center of the screen, and we set the foot to take the shape of the symbol pi. Step 5. Now we are going to define the key that we will use to play the game. The keys we will be used are right, left, up, and down arrow. Step 6. Here we set a snake initial position and ensure that its movement doesn't cause any bugs. This part is a bit more complex, so let me explain that what's happening. This line is mainly used to make the snake move from the left side to the right. And these lines are to ensure that the snake doesn't move in the opposite direction. So you can see that when the key equals key right, and then the next key doesn't equal the key left. So these prevent the snake from turning left when you move into the right, avoiding a potential collision. The concept of next three lines is the same as the previous one. Step 7. Now we need to set up how the game will end. The part basically means the snake head hits its own body. The snake head goes beyond the top or bottom boundary of the screen. And then the next one is the head goes beyond the left or right boundary of the screen. The last two are when any one of these conditions is met, the program will end and exit. For example, let's assume the screen size is 10 high and 20 width, and where the snake data equals 0, it means the snake hit the top of the boundary, so the program will end. Step 8. We need to set the new head coordinates of the snake and then insert them into the snake list, simulating the snake movement forward. The first line is calculating the new position of the snake head by updating its coordinates based on the current direction. And the other lines are used to determine the direction the snake is moving, and then adjust the coordinates by adding or subtracting accordingly. And then the final line is used to add a new head position to the beginning of the snake body list. Step 9. We need to handle the logic for when the snake eats the food, manage the tail when the snake moves, and then draw the snake appearance. Here is how it works. First, check whenever the snake has eaten the food, and when the food is eaten, it set food to null, which means it's disappeared. When the food is set now, we randomly generate new food coordinates and ensure they are within the screen boundaries. The second case is if the snake doesn't eat the food, it means the snake doesn't need to grow longer when it's moved. So we need to remove the leg segment of the snake and return. After returning, we use a blank space to clear the tail. And finally, draw the snake appearance and it's done.